Hi dear students, today we are going to see magnetic field produced along the axis of the current carrying circular coil. Okay, the last class we have discussed in an infinitely long straight current carrying wire. The same wire, suppose if it is made in terms of a circle, so how we can able to calculate the magnetic field at the point P. Okay, so let us consider there is a circular coil of radius capital R. Okay, through this there is a high amount of current will be passes through in anti-clockwise direction. Now, the center of the circle will be denoted, or the origin of the circle will be denoted in terms of O, and we have taken two small segment on the either side of the diameter. Okay, so this will be denoted in terms of C and D, and the small element or segment will be denoted in terms of DL. Okay, now, and this DL I is nothing but the current element. When the current is passes through in a small length, then it is said to be a current element. Okay, right. Now from the origin at Z distance, we have considered there is an external point P. With respect to the point P, we are trying to calculate the magnetic field with respect to C as well as D. Okay, then we have to calculate the total value of magnetic field will be associated or produced at the point of P with respect to the current flowing through the circular coil. Okay, right. And now from C, what is the distance? It takes R distance. Okay, R distance, and it is nothing but the unit vector. So it is the R vector, and there is nothing but R cap, unit vector. And now it makes an angle. Okay, which one? The point PC. Okay, PC, the line joining PC and the current element. It is denoted in terms of phi. And here theta. Okay, so here we have represented theta, and this theta is nothing but the angle between the PC and the current element. It makes an 90 degree. For example, the circular coil it is placed in the horizontal direction, and we have taken the point P in the vertical direction. So the angle between the PC and the current element it is nothing but 90 degree, and that's why here we have denoted that theta is equal to 90 degree. Okay, right. Now at this point P, due to this angle 90, the angle between PR and PC is also 90 degree. Okay, since this angle has become 90, which angle? The angle between PC and the current element is 90 degree. Because of that, this angle PR and PC is also 90 degree. And because of this reason, we have to resolve the compound into two with respect to the magnetic field. Okay, so this magnetic field we have to resolve into two compound. One is dB cos theta, this is the horizontal compound, and dB sin phi. Okay, dB cos phi and dB sin phi, and this is a vector horizontal compound, and this is a vertical compound. Okay, right. First of all, we have to try to find the magnetic field at P due to current element at C. So at this point C, with respect to the current element at C, we are trying to calculate, and the formula from Biot-Savart law, dB vector is equal to mu naught divided by 4 pi ideal sin theta divided by r square. And here theta is nothing but as we defined 90 degree, so sin 90 is nothing but 1, and substitute here, then this equation will be modified like this: mu naught divided by 4 pi ideal divided by r square. And this is equation number 1. Next we have to try to find the net magnetic field B vector at the point P. So now we have to try to find the net magnetic field. Okay, so net magnetic field is nothing but the total magnetic field at point P, and this will be denoted in terms of D vector. So it is equal to integration of dB vector. So what is dB vector? Mu naught divided by 4 pi. Okay, so here we have to substitute dB vector. dB vector will be written like this: integration of dB sin phi into k cap. Because how you can get this formula? Very simple. As we know that dB cos phi and this dB cos phi, Okay, the magnetic field which is associated by C at the point P, as well as the amount of magnetic field will be produced at the point P with respect to D, both will be equal. Okay, so this dB value is equal with respect to point C and with respect to point D. Okay, and both will be acting in the opposite direction. Okay, this dB cos phi will be acting along this direction, and this dB cos phi will be acting along this direction. So both of them is equal and opposite direction. So hence these two functions will be get cancelled each other. Then only dB sin phi alone will be acting along the z direction. Along the z direction, it will be acting along the z direction, and it will be gets activated. Okay, gets activated, and that's why they have represented here integration dB sin phi into k cap. Okay, why they have introduced k cap? Because it will be exist along the z direction. Okay, now we have to substitute dB value here. Mu naught I dl divided by 4 pi r square. Okay, into sin phi k cap. Into sin phi k cap. And mu naught I 4 pi, all these are constants, so take it outside. Then remaining we have to write inside the integration function dl divided by r squared sin phi k cap. Okay, and this is equation number 2. Now we have to try to find the value of sin phi, dl and r. Okay, all these values we have to find and substitute in this equation. Then you will get the net magnetic field at the point P. Okay, so to find that we have to substitute the sin phi, which is equal to, so here phi is nothing but we have represented here. So in this triangle OCP, from this triangle we have to apply the sin function. So sin phi is equal to opposite divided by hypotenuse. So opposite is nothing but r divided by small r. So r divided by small r, and this is nothing but equation number 3. And the same triangle OCP, we have to use the Felix theorem to find the r value. To find the r value, we have to use Felix theorem in this triangle, right angle, triangle. So in this right angle, triangle. Okay, right. What is Cp square? Cp square is nothing but r. So r square, which is equal to OC. OC is nothing but capital R. So capital R square plus OP. Okay, OP is nothing but Z. So Z square. Okay, and now this is the equation number 4. Next we have to try to find, because we need r value. So take square root. Okay, so therefore r is equal to square root of r square plus Z square. Or we can write in terms of r square plus z square power 1 by 2, and this is equation number 5. Now we can substitute this r value in equation number 3. So substitute equation 5 in 3. Okay, when you substitute, this equation will be modified like this: sin phi is equal to r divided by r square plus z square power 1 by 2, and this is equation number 6. Okay, next is substitute equation number 4 and 6. Substitute 4 and 6 in equation number 2. Okay, in equation number 2. So we have calculated what is sin phi value and what is that r square value, and both we have to substitute. When you substitute, you will get d vector is equal to mu naught I divided by 4 pi. Now we have to substitute r square value. What is that r square value? R square plus Z square. So 1 divided by R square plus Z square. And what about the sin phi value? Capital R divided by R square plus Z square power 1 by 2. Okay? Into k cap. Only the remaining things is nothing but dl. So integration dl, and this is nothing but equation number 7. Now we have to modify the 7th equation here. D vector is equal to mu naught I divided by 4 pi r divided by r square plus z square 3 by 2 k cap integration of dl. How we can able to get this one? Very simple. Here when you see this r square plus z square, and here r square plus z square power 1 by 2. So for example, if the base is same, you have to add the powers. For example, r square plus z square power 1 and r square plus z square power 1 by 2. So now the base is same, so we have to add the powers. So therefore r square plus z square power 1 plus 1 by 2. So taking this LCM, you will get what is happened. 2 plus 1 divided by 2 plus 1 divided by 2, you will get r square plus z square power 3 by 2. Okay, so this value only we have substituted here. Okay, straight away. And now this dl, what is the dl? dl is nothing but length, but here it is in terms of a circle, so the circumference of the circle. So dl is nothing but circumference of the circle and the formula for that 2 pi r. Okay, you have to substitute this value here. So when you substitute, you will get the above equation will be modified like this: mu naught I divided by 4 pi r divided by r square plus z square power 3 by 2 into 2 pi r into k cap. Okay, now this pi will be get cancelled and 2 and here 1 2 will be get cancelled. Then we have to multiply this to r. Okay, then this equation will be modified like this: mu naught I divided by 2 r into r, you will get r square divided by r square plus z square 3 by 2 into k cap. Okay, right. Next we have to replace. So how we can replace this? Very simple. If the circular coil having n number of turns, okay, the circular coil it has n number of turns. If it is a single turn, no problem. If it is a n number of turns, the same formula will be modified like this: B vector is equal to mu naught n. So this capital N is nothing but number of turns. Okay, so mu naught n I divided by 2 r square divided by r square plus z square 3 by 2 into k cap. Okay, suppose if you are trying to calculate the magnetic field at the center of the coil, which means there won't be no distance. Okay, the z becomes 0. So we have to take z is equal to 0 and substitute this condition in this equation. If you substitute here, this term will become 0. Then how this denominator will be modified? We have to modify like this. How? R square into 3 by 2. So we have to cancel this square. Okay, this 2 will be get cancelled. Then you will get r cube is equal to r cube. Okay, now this r cube we have to substitute. 2 will be get cancelled. Now how it will be? R square divided by r cube. R square divided by r cube. So here r square and here square will be get cancelled. Then this equation will be rewritten. How it will be rewritten? Very simple. B vector is equal to mu naught n I divided by 2r. So this is the magnetic field which is experienced at the center of the coil. Thank you.